Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. In this episode, we take a look at the final results of the Safe4RAIL project. What was learned, and what are the challenges in building a better train for tomorrow? I'm Peter Ballant from Technicon, and today we are in the offices of TTTech in Vienna, speaking with Arjan Geven about Safe4RAIL, a 2-year project which is near completion. With the efforts of nearly a dozen partners, TTTech contributed in this important effort, which ultimately strives to make rail travel safer by consolidating onboard systems. And if you're thinking, why hasn't this been done decades ago, you'd be right. Here's Arjan.
There is so many systems in the train. It's amazing that all of those are connected with their own wires. All of those computers are redundantly done in the train. So there is dozens and dozens of computers with kilometers of cable in each train set, which adds up to a huge amount of weight, a huge amount of power that is needed to support all these. And of course, a lot of maintenance, a lot of effort that is gone into the keeping these systems up and running.
And how is it that these trains, modern trains of today, have these separate components and they all operate independently? Is this a failure in the industry, or is it just because of the fact that a train consists of so many different components?
For one, it is definitely the second point. So there is safety concerns always when things become more and more integrated. So for developers of the specific components, and the train is built with components from so many suppliers, and all of them need to cooperate to build their specific subsystem. So the brake system is supplied typically by one partner, but this partner again is building on top of results from many different suppliers. So there is a very large ecosystem that is behind the building or the construction of one train. And now when we don't have technology that allows these players to cooperate nicely by separating concerns from a technology point of view, then it will be a big chaos, because all those suppliers suddenly need to interact with each other. So the only way to get them to integrate nicely on one platform is to make sure that the platform guarantees that they don't need to talk to each other all the time. And so the technology was not ready to support this kind of partitioning or this kind of isolation of the individual systems in a virtualized way. And this is something that we are adding here. But of course, hand in hand with the technology capability comes a kind of new development methodology or a new ecosystem structure of how those players are going to organize themselves in this new kind of environment, where perhaps so today a braking system has their own computer, which means they are supplying their own system, including everything, hardware, software, the braking system itself, obviously. And this is supplied by each individual supplier for the braking system, for the door control system, for the door system, including the door controls. With this kind of new technology, we are kind of changing a bit this architecture, because suddenly the door control computer might not be a physical computer anymore. It might just be the software for controlling the door. And the computer is a central computer on which this software is going to be integrated. So there is some changes that are going to happen in the ecosystem as well, based on this technology, where everyone kind of needs to find their new roles.
Are you looking at actually creating something, or are you looking at maybe creating standards so that train equipment manufacturers can all be working on the same platform, and then we sort of have this modular system where you plug in the door system and you plug in the lights and you plug in certain items into a backbone, perhaps? Is that kind of the goal?
Yes, exactly. So within Safe4RAIL, we are not focusing on developing the technology itself. The goal of Safe4RAIL is really to come up with this blueprint to make sure that everyone has the same picture, the same understanding of how these systems will be integrated. Because when we have systems that are laying side by side to each other in a federated architecture, you don't need to know too much about the other systems because you are not interacting too much with them. When all of these systems come together on one platform, then suddenly everyone needs to understand very well how they must interact with this platform. So here there is a big effort being undertaken to work together with the different train manufacturers, with the suppliers, to make sure that everyone has the same picture of how this integration shall be done in order to come to this reliable and safe architecture. So the main focus is really on let's say, creating these standards or this architecture, this platform concept. Then in the last phase of the project, we did do quite a bit of development to ensure that we have some proof of concept where we can also show how this is then practically done. Not on the level that it can be put onto a train now and people can drive the train and it will be completely safe, but to make sure that we can talk to the suppliers of the braking system, traction system, signaling system, and so on, and to the train manufacturers, of course, to the operators. There is in the end a Deutsche Bahn or an SNCF or ÖBB in Austria that needs to operate the train. So also for them, there is some influence of this system. And we need to get everyone on the table. We need to understand what are their needs in order to come up with a solution that is going to make them happy in the end.
So this project actually contributes to putting the European rail system sort of on the cutting edge of technology. If this is a successful project, it's a piece of making the European railway one of the best in the world, perhaps.
No, I think the European railway system is one of the best in the world right now. What is a big challenge is, let's say, in the interoperability of trains. The European railway, we have a lot of small countries compared to the US, compared to China, compared to many other countries in the world. If you look at Europe, there are small countries, relatively small countries, and each of them have a long history with railway. So there's roughly 200 years in which each country has developed their railway system with their own railway manufacturing, their own infrastructure, and so on. And now in the more recent decades, this has become more and more cooperative. But there is a lot of legacy also in these countries. And this has been very difficult in harmonizing in many aspects. But now there is a strong push from the railway manufacturers, from the operators, in terms of interoperability. So it's not only about having an architecture, a new platform for a train. It is also a lot about the interoperability between trains from different manufacturers. So there is a possibility to connect a train from a French manufacturer to a train from a German manufacturer, and they can operate on a French track or on a German track, which at the moment is difficult to impossible.
And when we talk about trains, are we talking here about passenger trains or freight trains?
No, we are definitely talking about passenger trains. So the complexity in terms of the train system is higher for a passenger train. Also, the cost point is different. Whereas a transport cargo train, there is no door control. There is not a lot of electronics in the cars. So the main complexity is in the locomotive. In passenger trains, it is a bit different. So we're not talking only about high-speed trains. We're talking about different types of trains. It's high-speed trains, regional trains, but also local trains or trams or subways. So there is different kinds of trains in different kinds of environments. They have different levels of complexity, obviously, but they have the same principal issues in terms of architecture.
When do you see these things happening? So if you look into the future, when do you see this system of this backbone and connect by Ethernet? And
if you take a look at the timeline, what we are talking, so this is an activity that cannot stop when we have the blueprint, right? So the paperwork is roughly done. We have an idea of how to do this, but now there is still a long phase until this can actually be implemented in a train. For this, we estimate, let's say, roughly 4 years from now on, where there is a next phase, which we just started actually. So with the end of Safe4RAIL, with the Safe4RAIL project coming to an end actually this month, there will be follow-up activities. So we did the blueprints. Now the next phase will be focusing on the implementation. So we are implementing those proof of concepts into a higher level of maturity so that we can demonstrate in the end that there is a network, that there is architecture, that there is a platform on which the applications can be integrated. And also that we show that this integration can be done. From there, so this is about 2 years activity. From there on, there will be another 2 years of moving from a demo system to a system that is in a real train. So we're talking about 4 years from now until you see something that is close to market introduction. 2022 to 2024 is kind of when you see this hitting the real train. Then there is some certification time that is needed in order to get this train onto the track. So this is kind of the time frame that we're talking about.
So how does the Safe4RAIL project contribute to the future of the railway in Europe?
The main goal of this system, it is actually not to increase the safety of the train. So I think if you look at trains in Europe, it's the safest transportation system that you have today. We will not make it safer by this technology. The goal is definitely to make it simpler, not so much for the passenger. The passenger will not notice, hopefully, that this system is there because it's completely in the background. What it will do is it will make it simpler, both for the train manufacturers, who have less work in developing new trains, making it more modular, so for them it's easier to put in new systems, to make the train more advanced. It will make it easier for suppliers because there are things that they do no longer have to care about. And it makes life easier for the operators because the operators have less parts that they have to maintain. They have less repairs for specific components because there's less specific components, which make things also easier to handle in terms of, let's say, components running end of life, out of stock or whatever. The maintenance engineers that have, let's say, an easier life. And in the end, the train being cheaper because all those things, when you can reduce on the efforts for the train manufacturers, you can reduce on the efforts for the train component suppliers, you reduce the efforts for the operators. In the end, the train is cheaper, train operation is cheaper. All of those add to more cost effectiveness in the train system, the punctuality and so on. We can put new systems into the train more easily because you can integrate systems later on onto the same backbone architecture without fundamentally changing or cabling or whatever things inside the train. So you will make also the upgradability of the trains or of this train control and management system more easy. And I think there are big advantages.
You had a unique way of testing some of your efforts with this project. You didn't need to rely on outside field testing so much. Can you comment a little bit about that?
Okay, so in this project, we do not only focus on the architecture. I think this relates to your question also. So on the one side, we develop these architectural topics for the network and for the computing system. The other part is related to improving the testability or at least the simulation capabilities of the system so that in the end we can test more of the systems outside of the track in the labs and ensure that we reduce the time that is needed to spend on the track because track time is expensive. It is difficult to integrate everything on a test train. You need to reserve this track time in advance. Any minute of this that we can reduce, it saves development time, it saves effort, and it saves money. So here we wanted to ensure that we get simulation results, but also testing in distributed environments where we connect the components together over the internet, basically, and see if they can cooperate to each other. What must be said, I think this is an important topic, is that it's not Safe4RAIL in itself. So in Safe4RAIL project, we might come to it later. The Safe4RAIL project is actually one of two projects that is dealing specifically with the train control management system. So it is part of this funded initiative by the European Commission, which is Shift2Rail. Shift2Rail is a 7-year program aimed at improving the competitiveness and the technology inside the trains in different areas. And one of those areas is the train control management system. There's two projects, as I said, dealing with this topic specifically. One is Safe4RAIL, the other one is Connecta. And Connecta is, let's say, the members project. So this is the project inside Shift2Rail that is directly linked to the, let's say, to the train manufacturers, to also the operators. So there's operators, manufacturers, and suppliers involved in this project. So it's not Safe4RAIL alone that is defining these architectures. It's a very close collaboration between these two consortia.
And now that this project has ended, can you tell us what you've learned? Were there any surprises, any unexpected results that came to light?
So for me, what was new, I'm not from the railway industry. So I'm working in electronics, I'm working in the aerospace department, and the train is not the same as an airplane. Okay, the challenges that you have in aerospace are similar. We also want to simplify electronic architecture. We also care about size, weight, and power of electronics, but we have less complexity somehow in the system when it comes to the dynamics of the system. Because an airplane is an airplane and it will not change over time. When you have a train can be coupled, decoupled. You have suddenly a longer train, a shorter train. You have very strong interactions with its environment through the signaling system. There is communication to the track. There is communication to the stations. So the train system is much more complex in certain aspects than an aerospace system.
If you look in the future up to 2030, for example, where do you see railway transportation at this time?
There are very interesting developments that you see all over the world being hyped, like these very high-speed trains that are coming. You see in general that the speed of trains is increasing, of high-speed trains. The coverage of train lines is increasing in certain areas of the world, especially if you look at the Asian markets. There is lots and lots of investments in the infrastructure, and things are changing there. But also in Europe, you see very strong improvements in the areas of autonomy. There's lots of tracks here, and especially those tracks that are used frequently. The goal is, let's say, in the next 10 years, is to also increase even more the capacity of these tracks. How can you reach this, and what is the role, perhaps, of also Safe4RAIL? Is that we want to ensure that there is safe communication within the train, and perhaps also in the future safe communication between trains, so that trains do not need these long safety distances to drive behind each other. And when trains can operate more closely together, then the tracking capacity can increase by a lot of, say by a factor 2 or 3 even. If trains can drive with a few meters distance, and we can communicate safely between those trains, so that when the first train breaks, the second train immediately notices and also brakes, and this can be handled safely, then this has a very strong impact on the capacity of especially these main lines.
Give us the names of some of your larger partners here, or your largest contributors.
Yeah, so the consortium is consisting of 11 partners. There is several research institutes and industrial partners. Very interesting is that it's not the typical railway consortium. So we are combining here companies, for my case, from aerospace technology and industrial automation technology, which is also inside TTTech, with companies like IAV, who is a strong partner in the automotive domain, to see what kind of technology we can bring in from those different domains that are at the benefit of railway. Then on the other side, there is strong railway partners that are well known in this community or have a lot of safety background, because in the end, these technologies are at the backbone of the train. If something goes wrong, this is very critical technology. So there is, for example, near Engineeria in the area of Bologna in Italy, who is safety experts. There is TÜV Süd is involved from a certification point of view. We have typical railway partners, Unicontrols or NewTech, which are suppliers of components in software that already are driving in trains today. But also university partners like University of Siegen. There is ICALAN, which is a research institute in Spain. And IFSTAR, which is a research institute in France. Obviously, there is also security concepts. So there is Technikon specifically also working on those. ELETEC is working on a specific kind of application. So we don't only want to see whether the system works in principle. ELETEC has experience in the braking system. So braking system is the one most critical function in the train. We want to ensure that we have an idea, a concept of how this specific system can be integrated into this platform. If we can do it for the braking system, we can do it for any other system.
Thank you for speaking with us today. Thank you also for your contributions to this project, and we wish you continued success in future projects.
Thank you.
This project has received funding from the Shift2Rail Joint Undertaking under grant agreement number 730830. This joint undertaking receives support from the European Union's Horizon 2020 Research and Innovation Program.